Hi, unlike the previous video, here we look at the case of a maximum. Here is our function, and the maximum point is right here. At this point, the function attains its maximum, and we want to look at the relationship between f and its derivative and the second derivative. So on the second graph below this one, we look at the behavior of the first derivative. It's easy to establish what it is doing. At the maximum point here, the tangent has slope equal to 0, so the derivative right here is equal to 0. To the left of this point, the slope is positive and the derivative is positive. To the right of this point, the slope of the tangent is negative and we see that the derivative is negative. And we arrive to the first order condition that exactly at this point where the function has a maximum, we have the first derivative turning into 0. Now, the second derivative, the sign of the second derivative, is established by looking at the tangent to the graph of the first derivative. Here, right at this point, the tangent is positive, so the second order condition would tell us that the second derivative should be negative. And again, the formal discussion of this fact is based on the Taylor approximation. X here is varying, so as in the previous case, the right hand side here is a parabola. This is a quadratic function of x, and because of the first order condition, the second term disappears. Because of the second order condition, this coefficient is negative and we have a parabola with branches looking downward. And my suggestion to anybody who tends to forget the first and second order condition is just to quickly draw graphs like this. And basically what happens is that the first order condition is the same for the maximum and minimum case. It's the second order condition that makes the difference. And the sign of the second order condition is easy to establish by drawing something like this, which could be just a parabola. In my case, this is a little bit more complex. It's not exactly a parabola, but you can draw just a parabola and see what happens with the second order derivative. Thank you. Bye.